I'm Anton Babkov, and this is the Climatalist Abroad. My previous chat with Janne Wallenius of Blakala covered a lot of ground, but there's one extra conversation I want to share with you. Consider this a bonus episode of sorts. Janne and I took a detour to discuss if the rollout of nuclear was a real option in the Australian landscape. Australia is phasing out coal, renewables are growing fast, and naturally, nuclear has re-entered the debate. But is it viable? Could Janne and Blakala's small modular reactors be a part of Australia's energy future? We look at what Australia can learn from Sweden's nuclear rollout, whether SMRs could repurpose old coal plant sites, and what's standing in the way from progress, from workforce challenges to regulations and public trust. With momentum building, could Australia take the leap? Or is nuclear just another distraction in the pursuit of positive climate action? Let's dive in.
So let's talk about the Australian context, and this is a bonus section for those that are interested in deep diving into the Australian context. I'm just going to share some of the discussion points that we've got in the Australian climate at the moment, and just to get your take. So broadly, Australia's energy transition is gaining momentum. You know, there's lots of positive momentum happening in renewables in particular. Nuclear has definitely entered the debate as of the last 12 months. Drawing from Sweden's experience, let's explore how your work could inform the way that Australia is tackling this. So first question, Sweden has been investing heavily in nuclear innovation recently, and Blakala is part of that journey. What lessons from Sweden could Australia adopt as it debates nuclear and explores investment? You know, is there a dipping the toe in the water? Is it you know, go all in? What's the balance?
Well, I mean, Australia has a good starting point in terms of its the R&D that's been done at ANSTO. And you have a research reactor. I mean, when Sweden built its first reactors, the experience from the research reactor was essential. It was really important. Then, of course, you need also to have experience from large-scale industrial building projects of some other kind. Sweden just had built its own hydropower nest, but there was a lot of experience in successful large-scale industrial projects. So that is sort of important to have. I mean, in Australia, you have the mining industry, which I think can provide similar capabilities, especially with the experience from the mining industry is valuable in terms of regulating radiation, industries which have regulates the management of radioactive materials. So there is certain type of expertise that is available clearly, and if one can leverage on that experience, it's useful. Then what was very successful in Sweden was a partnership between industry and government. So the Swedish reactor fleet was built by the ABB and in a very coordinated collaboration with the government. So the government placed orders for a certain number of reactors. The private industry placed orders for as many reactors, and there was a very efficient. That was a very efficient approach. So Sweden built 10 reactor units in 10 years, between 10 years, but between 72 and 1986, 14 years, we started 12 reactors, 9 of them were Swedish built, and that was the quickest build out of any of nuclear power in the world ever.
Wow.
Which means a country of a size like Australia may have the competence, the engineering, the industrial competence to do a very quick deployment of an advanced technology like nuclear power.
Especially with, I have a partner who knows how to build the right sort of factory.
Yeah.
So Australia's coal plants are being phased out. Some of them have been shut down already, and there's a gradual phase out planned. Could small modular reactors retrofit onto the sites of these coal-fired power plants to leverage existing infrastructure?
As I understand, this could be possible, yes. And then, I mean, the intent is similar in some other countries to use the existing infrastructure. So, I mean, a coal power plant is maybe size of a few hundred megawatts. So you could certainly, I think this is a very suitable idea, or this is a very interesting idea.
And how would it work as a practical matter? Because presumably the coal power is running its own turbine. Would you just plug straight into that system, or are you just using the site and the transmission distribution capability?
And the simple thing is to use the transmission capabilities, because that is not normally what's lacking. And if that is in place, it's already a good thing, because that would take time otherwise.
And in terms of geographic footprint, we're talking about a similar size footprint.
Yeah, absolutely. And also, I think, those coal plants are normally also located not in the center of a city. So, up some distance. SMRs are meant to be able to locate close to cities, but still, it's good to have them on a kilometer of distance.
Some safety is important. Okay. So, next question, specifically on this nuclear expertise, it sounds like we have some baseline capabilities around handling nuclear materials. We have some research capability around the existing nuclear reactor. We had an industrial capability from our mining sector, and they can do large scale projects. What else do we need? And what would it involve to mobilize those elements together to create something material?
You do need to start an education program. You need to educate nuclear engineers, which will take some years. Also nuclear operators. This is, normally done by let's say, high school engineers. But you need to have them in place, and need to have a sufficiently large set of skilled people to be able to regulate, to attract skilled people. And also you need customers. Because, for instance, and in Canada, the SMR development is driven by customers, our utilities, the mining industry. And things are happening there. What we see in the UK is that the deployment of SMRs is government-driven. It's not driven by the power utilities or by any industrial customers. And things are going more slowly there. Same thing in Sweden. But what we see that the first customers we see it's not for electricity, it's industrial customers for. Right. So you need to identify Australia customers that need what SMRs can provide, and which they might, so for instance, process heat. I think could be very interesting is to understand, because as long as there are coal power plants producing electricity, they will unfortunately be economically difficult to compete with. So you need to find a market niche where SMRs can be really, really so competitive that there's no discussion.
So you start with SMRs, particularly potentially in some industrial precincts, and then you move as you scale, and you rely on the economy of multiples. You then start to modularize or swap out your coal power plants through your modules. Understand? Okay, fascinating. Let's say Australia wanted to invest in SMRs. What kind of timeline and costs would we expect, and how does it compare to your figure of 500 million and at an 8 to 10 year cycle?
Well, because you wouldn't necessarily then need to have be paying for the first demonstration unit if you can rely on experience from other countries. Yeah, then we speak about. If you would purchase units from another country's factory, or then it would be fairly. As soon as those would be available, then that those can be procured, and that would be in 2035 for sure.
Got it.
Yeah. And then so you could deploy. So Australia could deploy a fleet of SMR starting from 2035.
At that point, do you have a range of ticket price for a 5 megawatt module?
So the 55 megawatt electric modules, the reactor itself would be about $100 million. And then the fuel, the uranium fuel, is currently very expensive. So that would be another 200-300 million.
Well, we have a lot of uranium fuel in Australia.
Exactly. So that's an aspect. But what Australia should actually, this would be also a very interesting business project in Australia is to actually invest in plants that convert the uranium ore to uranium fuels like uranium oxide or uranium nitrate. Because that would, irrespective if Australia actually builds SMRs or not, would be very profitable industry. And then as a first step, that is something, and that can be done very soon and very quickly. But that's something that needs to be done, because it's to ship the uranium away somewhere else and then take it back. That's also
it's like it does sense. Yeah. I guess being a regional center in that context becomes quite important.
Yeah. But then we have the program of education, identify customers, look for potential niches in the nuclear industry. The fuel supply chain would be, I think, a way to do it.
Yeah. And then final question on this point. So, as it no doubt was in Sweden, we've got a very mixed public opinion around nuclear. Incremental steps that could be taken to start to build trust. Yeah, right. That is safe and necessary.
Mm-hmm. Yes, to build trust is important, of course. When Sweden located its nuclear waste repository, we had a competition between municipalities. And in the end, one of the nuclear power plant sites, municipalities won the competition, and because they have huge support for nuclear, 80% in favor of nuclear locally, and they actually, they competed. They wanted to have their repository.
Wow. Okay.
Yeah, and and this nuclear waste management company was smart enough to say, okay, if we will invest this amount of money into your municipality if you agree to have the repository, and they actually invested more in the municipality that lost the competition, so that they would be encouraged to take part in the competition.
Wow. Okay. So there's got to be a quid pro quo with the first communities, and you have to focus on the areas where.
I don't know exactly where your reactor is located, but for sure that is that I would have a look at that site.
Yeah, that makes a lot of sense. I suppose they're already used to it, right? And this would be for that demonstration. I guess, do we need a demonstration plant in that context?
You might not need it, but it depends. If you're not going to develop your own domestic reactor technology, then no, you just go it.
Well, yeah, I guess that's the opportunity that the way that I see this is the opportunity that your technology and your approach specifically presents is the capacity to pump out these things like you pump out cars and, pop them in places. What strikes me as interesting from our conversation is that your company, the way you built your company, you're very efficient at constructing things, based on your personnel footprint. I wonder if then you will also be quite good at operating things, because presumably these small modular reactors are going to be simpler to operate. You're going to be designing that downstream. So is there a world where you don't have to develop a domestic nuclear capability subject to, the relevant supply chain, value chain issues, safety issues, regulatory issues, that actually you act as an operator of these plants? I come from a software as a service background where we live in a service, right? So is there and first of a kind technology is looking at this as a service deployment model very broadly. Do you become a global power utility as opposed to a manufacturer of stuff that you ship? I think that's where I see what's really interesting, the direction.
Yeah, it's true. So operations as a service, nuclear operations as a service. This is a very interesting business area, and we ourselves in Blika we are not seen as ourselves as in that. field, but there are other companies that are really doing this. So that currently are operating reactors for in the Nordic countries that look seriously into this. So I think there will be companies offering operations of nuclear power plants as a service.
So I guess there's an emerging ecosystem of this happening at scale. Yes. Brilliant. Fascinating.